This is Jo Karen Hudson. We're starting Module 12 today. This is actually Section 12.1. The section is on exponential expressions and polynomials. Let's start with the definition. An exponential expression consists of a variable raised to an exponent. Let's look at some examples of exponential expressions. 5x squared is an example of an exponential expression, as is -1/2 x cubed. Also, y to the 4th power is an example of an exponential expression. Let's think about what the coefficients of these expressions are. The coefficient of this first expression is 5. The coefficient of the second expression is the -1/2, and the coefficient of the third expression is that understood 1. Now let's look at the bases of the expressions. The base of that first expression, 5x squared, is x. The first base is x. The base of the second one, -1/2 x cubed, the base of that expression is x. And the base of the third expression is y. And lastly, we're going to look at the exponents. The exponent on the first expression is the squared. It is a 2, the exponent on the variable. The exponent on the second expression, -1/2 x cubed, is 3. And the exponent on the last expression is 4. Exponents can also be called powers. Evaluate the following expressions. Example 1. We would like to evaluate the expression 5x cubed when x is equal to 2. And that means that we're going to plug in 2 where the x is. So that we will have 5 times 2 cubed. Now when we use the rules of order of operations, please excuse my dear Aunt Sally, we know that we have to do exponents first, so I'm going to take care of the 2 cubed. 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So I'll have 5 times 8, and when I multiply 5 times 8, I get 40. Now I'd like to take that same expression, 5x cubed, and evaluate it for x equal to -2. So I have 5x cubed, and I want to wrap my variable in parentheses. And then I'm going to plug in the -2 where the x is. 5 times -2 cubed. And I'll need to take care of -2 times -2 times -2. -2 times -2 would be 4, and 4 times -2 would be -8. Whenever I raise a negative number to an odd power, it turns out to be negative. If I raise it to an even power, it turns out to be positive. But this is an odd power, so I'm going to have 5 times -8, and 5 times -8 is -40. Now let's get some more definitions. A polynomial is an expression that has one or more expressions that are being added and or subtracted. The exponents must be whole numbers. That means they can't be negative, not negatives. There can be fractions in the coefficients, but there are not fractions in the exponents. No fractional exponents. No fractional exponents. And there cannot be variables in the denominator. The highest exponent of a polynomial is called the degree of the polynomial. The degree is the highest exponent. A polynomial is classified as a monomial if it has one term, a binomial if it has two terms, a trinomial if it has three terms, and it's called a polynomial if it has more than three terms. We just refer to it as a polynomial. For each expression, determine if it is a polynomial or not. If it is a polynomial, give the degree and the class of the polynomial. Okay, first of all, when we're deciding if it's a polynomial, we want to make sure all the exponents are whole numbers. We also want to make sure there are no fractional exponents. And we want to make sure there are no variables in the denominator. So all of these exponents are whole numbers. This is a 1. There are no fractional exponents. They're all whole numbers. And there are no variables in the denominator. So this one, yes, is a polynomial. It is of degree 3. The highest exponent will tell you what the degree is. And it is just classified as a polynomial because it has 4 terms. This second example, x squared minus 5 over x, we cannot classify this as a polynomial. It is not a polynomial because it has variables in the denominator. It is not a polynomial. The third example, let's see, this one has 3 terms, so we could classify it as a, well, let's decide if it's a polynomial first. Let's see, all of the exponents are whole numbers, and there are no variables in the denominators. We have no fractional exponents. This is a polynomial. Yes, it is a polynomial. It is degree 10. The highest exponent here is a 10, and it is classified as a trinomial because it has 3 terms. Now let's look at this one. Y to the 1/2 plus y to the 10th. Let's see, this one is not a polynomial. It is not a polynomial because there are fractional exponents. It's not a polynomial. Example 5, is this a polynomial? Let's see, all of the exponents are whole numbers. There's no variables in the denominator, so yes, this is a polynomial. It is degree 1. The highest exponent is 1. It is degree 1, and it is a binomial because it has 2 terms. This is a very good example. This is a polynomial, yes. Now here, the understood variable is x to the 0. This is just a constant, but it has an understood variable of x to the 0. The degree is 0, and it is classified as a monomial because it has 1 term. Example 7, is this a polynomial? The answer would be no, and it's because -6 is not a whole number. All of the exponents have to be exponents, must be whole numbers. Simplifying a polynomial. Combine like terms by adding or subtracting the coefficient and keeping the variable part the same. Write the terms in descending order, starting with the highest exponent first. So we want to simplify the following polynomial. So we want to combine the like terms, and then we want to write the terms in descending order, starting with the highest. So I'm going to combine the like terms. The 1x squared and the 2x squared would give me 3x squared. The negative 5x and the positive 6x would give me plus x. So I have simplified that by combining the like terms. Example number 2. I want to simplify this by combining the like terms. I'm going to start with the highest exponent. Let's see, x cubed. There's only one term that has a cube in it, so I'll start by writing 3x cubed, and then I want to add the negative 1x squared and the negative 5x squared. That will give me negative 6x squared. And there are no x terms, but if I add the 4 and the 2, I will get positive 6. So I've simplified this, and I have a trinomial. I'd like to simplify this last one. 2y to the 4th minus 3y to the 4th minus y squared plus 1/2 plus 1/3. And I wrote them side by side, just the like terms side by side, just so that it would be a little easier for us to see. 2y to the 4th minus 3y to the 4th would be negative 1y to the 4th minus y squared. There's not any other squared term to add it to, but I have to add the 1/2 and the 1/3. Now, in order to add 1/2 and 1/3, I can either do it on the calculator, or I can get a common denominator and do it by hand. 2 times 3 is 6, and 1 times 3 is 3. 3 times 2 is 6, and 1 times 2 is 2. So that I will have negative 1y to the 4th minus y squared, and 3/6 plus 2/6 would be 5/6. It is not necessary to write that negative 1 in the front. You can also have the answer written just like this. You will need to do the homework on section 12.1 as well as the quiz on section 12.1. This is Jo Karen Hudson speaking. Thank you and have a wonderful day.